All right, so we're going to be solving logarithmic equations. Yesterday we solved exponential equations. So here are our steps to do that when we have a log equaling a number, so like this right here. We're going to condense and isolate the logarithm. On 1 and 2, they're already condensed and isolated because it's just a log equal to a number. But if you look at, like at number 4, I would need to condense this part and isolate it, so I'd have to move that. So you've basically got to get just the log all by itself. And then we rewrite it in exponential form, which we know how to do. And then this is the super important part. We solve and check for extraneous solutions. So just because we get an answer doesn't mean that they all will work, because your parent function for a log looks something like this, right? So what's the domain of this function? My little purple function. 0 to infinity, okay? So that's the only allowable inputs for a log. So can I take the log of a negative number or 0? No, I can't. So if I get a negative answer, like whenever I solve for x here, okay, so if I get a negative number for x, that might be okay. I would just have to substitute it back in and make sure that this entire value isn't negative, because I can't take the log of a negative. So basically you have to check your answers. Okay, the actual value doesn't matter, it's just whether or not it's positive or negative. All right, so we are going to start. Let's see, we're not doing every single one of them, but we are going to do number 1. All right, so I've got log base 2 of 3x minus 4 equals 7. So there's no condensing that's necessary. This is already isolated, so I can just rewrite it in exponential form. 2 to the 7th power equals 3x minus 4. Okay. Then 2 to the 7th, that'll be 2, 4, 8, 16, 32, 64, 128, right? So 128 equals 3x minus 4. I add 4 to both sides, and I get 132 equals 3x. So x equals what? 44. Okay, so before I box it, I want to check it. So when I take this 44 and I substitute it in here, if I multiply by 3 and then subtract 4, am I still going to have a positive number? Yes, like I don't care what the value is, but clearly if I multiply by 3 and subtract 4, I'm good. So that is my answer. Okay. All right, let's look at number 2. This is already condensed. It is already isolated. What is the base here? E. So I'm going to have e to the 9th power equals 2a, right? So then, what am I trying to solve for? A. I'm trying to solve for a. So what would I do next? Divide by 2. So I'm going to divide both sides by 2. So I get a equals e to the 9th divided by 2. So, because remember, e is just some number. It's 2.7 something, but that doesn't even matter. So the actual value of this, whatever e to the 9th divided by 2 is, I know it's positive. So when I substitute it in here, this stays positive, so I'm good. That is my answer. Okay. Any questions? Alrighty, we are going to skip number 3, and we're going to go to number 4. All right, so the first thing I want to do is I'm going to move this 4. So this gives me 2 times log base 9 of k squared plus 2k equals 1. So with that 2, I have a couple of options. I have a power rule, so I know that this 2 can become an exponent right here. I mean, that works. Then I would have to square this thing, which is fine. I'm capable of doing that. But what's another option for me to take care of the 2? What else could I do algebraically? It really has nothing to do with logs. I could just divide. Couldn't I just divide both sides by 2 and divide it out? So again, it could be an exponent or it's being multiplied here, so I could just divide it, and that would make my life a little bit easier, I think. So we're going to do log base 9, k squared plus 2k equals 1/2. So now I have my log isolated and condensed. I'm going to rewrite this. So I'm going to get 9 to the 1/2 power equals k squared plus 2k. So what is 9 to the 1/2 power? This is the square root of 9, which is 3, right? So, and this is a quadratic, and I got to set it equal to 0. So 0 equals k squared plus 2k minus 3. And I must be writing really big because I didn't run out of room before. Now I'm going to need to factor it. This will be k and k. So it'll be plus 3 minus 1. So we get k equals -3 and 1. Okay, so before I box it, I need to check to see if they both will work. So the positive one, I am confident the positive one's going to work, right? Because it's just going to all stay positive. But then that -3, well, if I square it, I get 9, right? And then that'll give me a -6. So is -3 going to work? Let's stay positive. Yes. So we're good. Okay. Any questions on that? Alrighty. Good. All right, so let's see. We're going to do number 5 now. Yes. So here I do need to condense. I've got these 2 logs that are being added. So what's my rule for that? What do I do with these 2 pieces? Multiply. When I add 2 logs with the same base, I get to multiply those arguments. So I'm going to get log base 4, and then 2v plus 3 times 2v minus 3 equals 2. So the 2 binomials that I need to multiply, are they going to be pretty easy to multiply? Yes, because that's a what? Difference of squares. Good. So I'm going to kind of combine some steps here. I'm going to go ahead and do 4 to the 2nd power equals, and then I'm going to go ahead and multiply that. That'll give me 4v squared minus 9. I have a quadratic, so I want to set it equal to 0. So I'm going to get 4v squared, and this is going to be 16. So 9 minus 16 will be a -25. Then I'm going to need to factor. Is that going to be pretty easy to factor? Yes. And so 0 equals, and this will give me 2v plus 5 times 2v minus 5. So v will be equal to -5/2 and 5/2. So when you test these, you always go back to the original one, and it would have to work in both of these. Well, the one that's more likely to fail than the other one is the second one, so I'd just start with checking that one. And so I'll start with my -5/2. So -5/2 times 2 is a -5 minus 3. That's bad, right? That's not going to work. So then I test my +5/2 times 2 is 5 minus 3. That's good. And I would also have to check it in here. Well, everything would stay positive, so that's fine. So my answer in the end is just v equals 5/2. Okay. Any questions? All right, number 6. Well, here's another one where my little fraction bar got away from me, so put him back in. Okay, so this 1/3, so on, I think the one right above it there, we divided both sides by 2 instead of making it an exponent. Well, I could multiply both sides by 3, but then I'd also have to multiply that by 3, then that would have to become an exponent, and that's a mess. But I really think that taking 27 to 1/3 power is probably going to be a good thing, right? That's not as yucky as the other one looked. Then these 2 are going to end up with some multiplication, so that means I'm going to get the natural log of 27 to the 1/3 power times x minus 5 equals 4. So 27 to the 1/3 power is what? 3, because it's the cube root of 27. When I rewrite this in exponential form, what's my base? E, because it's a natural log, so it's e. So I would have e to the 4th equals, now this becomes 3, right? And then it has to be distributed, so I'm just going to kind of do that one time. And with 3x minus 15. Okay. It's fine to skip steps as long as you're not making careless mistakes when you do it. Sometimes it's dangerous, and you kind of know whether, I mean, some people are like, I never skip steps because I know I'll mess it up. But, you know, you have to have the first one where you kind of substitute everything in. You got to have the last one, but it's okay to mix things up. All right, so again, we're solving for x. So I'm going to add 15 to both sides. So I'm going to get e to the 4th plus 15 equals 3x. Then I'm going to divide both sides by 3, so x equals e to the 4th plus 15 all over 3. And I could write that differently, like split, but there's no need to. Leave it like that, you're good, okay? So before we box it, because it's possible, like over here where we marked this one out, it's possible that we could have marked them both out and our answer is an empty set. So you always have to check like anything you have. Now, this actual value here, I don't need to type it in the calculator. I don't need to know exactly what it is. All that matters really, nothing's happening here. All that matters here is that this would have a value greater than 5. As long as the value is greater than 5, I'm good. So can you tell by looking at this if it would have a value greater than 5? Hopefully, because 15 divided by 3 is 5 itself, right? And so as long as this is something greater than 0, I'm good. Clearly, it's something greater than 0. No big deal. There's my answer. Any questions at all? All right. Then I want you to work on the next one, number 7. Okay, so once I get to n equals, I've got my -5 and my 7. Are they both going to work? What do we think? No, because when I substitute -5 in right here, I get -8, so that's a no-go. I check 7. 7 minus 3 is good, and then that's positive, so then I just have n equals 7. Any questions at all? We're good? Awesome. All right, let's do 8 together. So here, I have 2 logs with the same base, and I'm subtracting them. So what's my rule? What does it turn into? Division, yes. So this is log base 2 of c squared over 3c minus 5. On that assignment that I graded in CAMI, there were quite a few people on the subtraction part that was actually putting a log over a log. That's not what's happening here. It's one log. It's condensed to one log that has division. So then that equals 2. I'm going to rewrite that in exponential form. So 2 squared equals c squared over 3c minus 5. So the easiest way to attack this is to go ahead and multiply both sides by the denominator. I know this is going to give me 4. So when I do that, I'm going to go ahead and distribute and get 12c minus 20 equals c squared. It's a quadratic, so I want to set it equal to 0. I don't want to move everything to the left because I don't want my squared to be negative, so I'm going to move everything to the right. 0 equals c squared minus 12c plus 20. And I have two binomials. My signs will both be negative. So what are my numbers? 2 and 10. Yes. So that means that c is equal to 2 and 10. I got to check them. So 2 times 3 is 6 minus 5 is positive, and then clearly 10 will work, so they both work, and that's that. Okay. Any questions? All right. So all of those were if we have a log by itself or multiple logs equal to a number. Another way that you could see these is if you have a log equal to a log, okay, like I have here. Now, you could make it equal to a number by subtracting it over and setting it equal to 0, but there's another way we can attack this here. So we still condense them on either side of the equation. Then we also have a one-to-one property for logs. So if log base b of x equals log base b of y, then x has to equal y. Right? If you take the log of two things and they're equal, then whatever you were taking the log of has to be the same. Then we solve and again check for extraneous solutions. All right, so number 9. To condense, this is going to become an exponent up here. So I'm going to have log base 4 of 4p plus 3 equals log base 4 of 16p to the 4th to the 1/2 power. All right, so now I have the logs have the same bases on each side, so these two things have to be equivalent. So this is going to be 4p plus 3. Let's go ahead and simplify this. Now, this is if, let's say that this one had been to the 1/2 power. I wouldn't get to take this to the 1/2 power and this to the 1/2 power. It doesn't work that way because there's addition. Here, there's not addition. 1/2 power means square root. So I'm going to take the square root of 16 and get 4. The square root of p to the 4th and get what? P squared. Okay, so I'm going to let you go ahead and finish this one up. Did it already? Oh, I'm sorry. I thought you still had your head down from the time before when I just didn't look up. Okay, so once I get here, p to the -1, or not p to the, but p equals -1/2 and 3/2. So this negative, if I have -1/2 times, that'll be positive, so I'm good, and that'll be the fourth power, that'll be positive. That all stays positive, so we're good. I'm not sure if I said this yesterday or not, but I don't know that I did in every class, so I'm just going to say it again in every class today. If this is the part that you are struggling with. Like either understanding these exponents or even being able to factor things like that, that is not pre-calc. That is algebra, that is prior knowledge, and you need to have good skills for that. If the only way you're getting through this is with photomath or those other millions of things that are out there, I mean, I know they're all out there, I know they're being used. For some of you, it may be that's the only way you can do it, that's bad. I'm not saying that those aren't evil things, calculators aren't evil. If you're using it to check yourself, that's good. Do it, use your own little brain, and then use it to check yourself or to help yourself figure it out. But if that is literally the only way you can get through the difficult factoring or even easy factoring, then as cheesy as it sounds, you're only hurting yourself, because you're only going to get out of this what you put into it. And there's a lot of things that I can't kind of control and help you build certain things at this point, because we're all kind of on our own. If you do end up getting through this school year in this class with those kind, just using the little cheats the whole time, you will not survive in calculus. I don't care how you take it and where you take it. So it's important that you remember for yourself that you've got to, you got to train yourself that you have to actually practice these things. Okay, I'm just saying that. I'll get off my soapbox now. All right. If there's no questions on number 9, go ahead and take care of number 10. Okay, so once I get here and I have this -9 and this 7, do they both work? Will the -9 work? No. Will 7 work? Yep, so A equals 7. Okay. Any questions at all? We good? Alrighty.